as you know, part of the accessible wayfinding toolbox involves visual assistance like Be My Eyes, which is, as you know, part of the Goodmaps offering on the Explore app. And I think we'll get into very quickly here talking about what are some of the wayfinding challenges going forward. And that may take a little bit of reflection on where are we now? How have we gotten where we are? What are the different components of accessible wayfinding? There are really three major pieces. One is positioning, another is the map data, and finally the user interface. And we have two very good experts on both of these, all three of these topics, Nick Giudice and Tim Murdoch. So I'm going to pass it over to Nick to begin with and talk about positioning, mapping, and the UI. And I know, Nick, the UI is of particular interest to you. How do we make wayfinding something that blind people can use affordably, accessibly, and productively?
Thanks, Mike. Yeah, and hello, everyone. Great question. We probably could all go on about this for a long time. I'll try to be brief. So, as Mike said, these three components are all critical aspects, and each of them has relevance to accessible wayfinding for blind folks, low vision folks, and anyone else. I'll start with the user interface, or the UI, which is oftentimes done at the end. And that's part of the problem. I think that one of the things moving forward, Mike particularly has been a champion of this for years, as you know, have some others that have really thought about accessibility and navigation. But for this to really work, we need to think about the user interface right alongside some of these other more engineering, technical aspects of localization and mapping, and think about how they all relate to each other. One of the things that I think is really critical moving forward is thinking about user interface in a way that allows us to tap what I think of as kind of how, modeling more on how we actually use different types of information in our brain. So using what you can think of as bio-inspired interfaces. Our brain has all these different inputs that we use, right? So I'm congenitally blind, so I don't use my visual input as well as some, but I use some vision, obviously hearing, touch, smell, taste. And we're really good at processing and integrating all this information into this one synthesis. But most of our interfaces are visual, and most of the interfaces that are not visual use language, which is really efficient because we speak it, it's simple, but it's also not inherently spatial. So if I say go over there, unless you point or you do something with your head, the words themselves mean nothing. I could just say eat chocolate cake and it would have as much useful spatial content. And so figuring out how to use language in a way that's understandable and takes less cognitive effort and is something that's very quick and precise is difficult. And so if future interfaces can use more perceptual information that directly conveys spatial content, because navigation is about space and interacting with space. And these other senses that I mentioned that the brain does, they're very good at spatial content, vision, audition, and touch. And so what I'm really excited about in some of the areas that I'm working on, and some others are certainly doing as well, is using things like touch. So can we make real-time maps? And we may talk a little bit more about that, but we're using vibration-based maps that allow you to feel the face of your iPhone and to feel, the route that you're on or the relation around you as you're getting the narrative instructions, or using spatialized audio. So hearing things out in space to your left or to your right, instead of saying, Mike is at 10 feet at 11 o'clock, you have to be able to process, well, what the heck is 10 feet? If I only think in yards, or half of people now don't know what 11 o'clock even means if they just do digital interfaces. So if you hear someone localized in 3D space, the Microsoft Soundscape project is a really great commercial example of a product that's using this. So I think as we move forward, more interfaces that use these types of spatial interfaces that integrate the different ways that our brain already is really good at conveying multisensory or multimodal information, and moving beyond just a visual interface for sighted folks or just a linguistic-based interface for blind folks is where we're headed. And
Yeah,
I'll pass it on.
yeah, Nick, thank you. And certainly, I know you studied under Dr. Jack Loomis, and the kind of 3D audio, the spatial presentation of information that is so popular and so effective with Soundscape goes all the way back to the mid 90s and what Jack Loomis did at UC Santa Barbara. And
1985, I think, is when he first proposed this. Yeah.
yeah, I mean, it's, but the advent of headphones that don't cover your ears has really made it more practical than it was back in those days. And we've tried to incorporate a lot of user interface components, best practices into the Goodmaps Explorer app as well. Tim, let me shoot that over to you for the user interface. How are you guys focusing on that with Waymaps, and what's your thinking on this topic?
Thanks, Mac. And I completely agree with Nick. I think the user interface for us is such a central part of the whole proposition. We've been working with the Royal Society for Blind Children here in the UK for a number of years now, and I think the real heart for us is the confidence to be able to go out and to be able to get about. That it's the confidence that gives you that freedom. And so we've been working on a number of different fronts, and I think we've driven the user experience through a collaborative process to effectively define a standard. So one of the things that we've been really keen on is to drive forward the new CTA standard that came out fairly recently, that actually is all about giving audio instruction to vision impaired people based on where they are. And so, as Nick was saying, to be able to say, go over there or turn to left to 3 o'clock, these are really complex things you need to be able to get right, which actually plays to the other two things that Mike mentioned as particularly important. So we've got to get the user experience right, but we've got to get good maps. So we've got to be able to understand the environment that you're in. But if we're going to give a really good user experience, we've got to be able to automate those instructions. And those instructions need to be really sensitive to not only where I am, but also to where I'm facing. So if I'm facing in a particular direction and I give an instruction, or I receive an instruction, I need to be contextual. I need to be able to understand, I'm actually in this place, I'm trying to get to that particular destination, but I'm currently facing this direction. So if we can give those instructions which are contextually sort of aware, then what we can do is we can give a lovely, really integrated and confidence building experience. And that for us is the heart of where we're going. So we've been working really hard on developing a location technology that works on your phone that gives you that step-by-step accuracy so that we can give you that confidence to be able to get out in not just one environment, but in multiple environments. And that for us it becomes a bit like an audio-based augmented reality. So if you look at the things like the Bose sunglasses, which give you this 3D soundscape that is sensitive to where you're facing and how you turn your head, we love that, because actually that's a really powerful way of delivering the sort of experience that we think is really, really important.
Yeah, well, you mentioned that, and of course, it's sometimes it's one step forward, two steps back. And I know those Bose sunglasses, the newer models, now won't have the head tracking component. It's the older ones. So, but we still have the ability not to have our ears blocked, and that's been fundamental to using any kind of mobile accessible technology. You mentioned CTA, that's the Consumer Technology Association standards, and it's interesting because of course standards mean here are some guidelines, this is what we suggest you go by, but that's of course different than regulations. I mean, it's up to people to comply and to go along with something. And I think some importance of having uniformity among apps is the fact, for example, at Goodmaps, any data that we create for indoor mapping will be shared free of charge with other apps. So then a blind person has their choice of their own user interface, but they would have the benefit of the content which the venues will pay for. But since the app is free and it can be shared among different accessibility apps, then blind people have options, which is really a huge benefit. Let's touch a bit more on another key component of accessible navigation, and that is positioning. And of course, outdoors, we're all used to GPS. We know how that works and how it doesn't work. And everybody pretty much agrees on the final frustrating 50-foot problem. And a lot of different organizations are trying to address that. So let me have both of you think about that a little bit and mention it, and then segue into indoor positioning, because that's the new pioneering frontier for accessible navigation, indoor mapping and positioning. Nick, you have any comments on this part of the equation?
Yeah, it probably one of the most influential talks I had on this is something, Mike, you won't even remember. So sometime in like 2002, we were talking and we were complaining because you had product that you had at that point, and we were trying stuff and it wasn't exactly right. And at some point, you're like, if you waited until GPS was at centimeter accuracy for every 1 week, we would be waiting for years and years and have nothing. And like, it's so important to just get mostly there and then let people use their own skills. And yeah, it doesn't mean that it's perfect, but it means that we're close. I think that's really a critical thing to remember, because even though indoor positioning isn't good yet, and whatever we want to say, the last X, last meter, last 2 meters, last 3 meters, but whatever you need to get to. And at some point, the issue isn't can you get to 1 centimeter or 2 centimeters, it's can you get someone to where they want to get to? Can they perform what they want to be able to do? And the fact that people are now working on it, and it's getting so it's it's good, it's getting so it's good, not great, but good, and it's working. It's getting you there. That's good enough to really begin to feel that this is going to work. So yeah, my feeling here is, one of the problems is that unlike outdoors where we have this one system, GPS, that works pretty much everywhere. And yes, there's line of sight, if urban canyon, if you're under foliage or whatever, but inside there isn't one thing generally. So if you're going to use radio frequency or going to use, beacons, Wi-Fi, whatever, you need to put them in all these places. And so there's a lot more infrastructure build out. And so there's other places that I've tried, like we've tried magnetic signatures where you try to use the, the magnetic information in the building to localize you. And that's kind of cool and it kind of works. But if you get away from this, the wall, it doesn't work. Or if elevator goes by, it makes some sort of noise that screws everything up. So I think the answer here is going to be some sort of sensor fusion where it's going to be multiple technologies, multiple people really working together. And I think that some of the technologies that were initially thought of as not going to be the solution, and I'm interested in what you both of you think, are now actually going to be a big part of the solution. So using cameras, using optical LiDAR, things that are being able to take real-time imaging in some form and using that for positioning instead of just using Wi-Fi or beacons, which I think were kind of what everyone thought would ultimately work, or cell phone positioning. So yeah, I think we're getting there. I think the future is going to see this nut crack. There's a lot of really big names that are interested in, want to do this. From everyone needs to do indoor localization. It's not just blind folks. It's, there's lots of reasons. But I think we're going to see it's going to be using lots of different sensors that work together and hopefully, seamlessly share that information.
Yeah, a laudable goal. And as you know, both of you, indoor navigation is something, and the positioning has been worked on for at least 25 years. And the big breakthrough was really when Bluetooth beacons and Wi-Fi fingerprinting started to be tested and rolled out commercially about the last 8 to 10 years. That was a big jump forward, and I think we're now poised for additional jumps forward as we put LiDAR and camera-based positioning into practice, which is what we're using on the Goodmaps Explore app. How about you, Tim? What are you thinking about in terms of positioning?
Yeah, so I suppose I've got a bit of a minority report here. So we tried the beacons for many years in when we created the standards, and actually the beacons and Wi-Fi just simply doesn't give you the accuracy that you need internally, and also it is just one of those impractical things to be able to deploy at scale. And obviously, one of the things we are trying to do is we're trying to provide this service in any location. And so we've actually developed a dead reckoning technique that does the sensor fusion that Nick was mentioning earlier. that actually follows people around as they walk around any building. We don't need to survey any Wi-Fi. We don't need to survey any magnetomic sort of interference, and we don't need to install beacons. So what we were able to do is we're able to have the outdoor-indoor experience as a completely seamless experience. And the beauty of that is, as GPS gets better, and it will be getting better over the next few years, and there's some amazing things going on in that, the outdoor environment will get better. And also, as Apple and Google just naturally extend their indoor location competence, so they're providing out of the box now Wi-Fi fingerprinting for specific locations. Those are all really good things. And then what we're able to do is we're able to take advantage of that with our current algorithm that gives us a really accurate location as people walk around. And so I think where we see a dead reckoning technique gets us to the last meter. Where we see cameras and LiDAR, we think that's really important, but that gets you a much more dynamic environment. If there's an obstruction in the way, if someone's left a scooter on the sidewalk, we can see that so that's where LiDAR and image recognition comes in. So what you've then got is you've got the last inch comes from cameras, which is a relatively computationally expensive thing to do. But what we're able to do right now is to give a location that works on an old school iPhone 7 or so. So it's fairly old school technique that actually becomes available to everyone with equipment they've got today. All they need is a pair of headphones, ideally bone conducting, so it doesn't include the sound. And what that then allows us to do is to get people out and about with the equipment that they've got today. And as time goes on and new techniques emerge, we're able to fuse that information into the current platform to give them a much deeper, better experience as time goes on. So it plays to where Nick was going, which I completely agree with. What we have today is an ability through dead reckoning to give a great experience. And where we absolutely will be going over the next few years is it's just going to get better and better and better, not just for those with vision impairments, but actually for all sorts of users, whether they be sighted but actually require some other assistance, or whether they just be a tourist in a foreign land. We want to be able to give a broad range of experience using that fundamental same approach.
Yeah, Tim, let me ask you this. Dead reckoning has been the holy grail forever. And the problem really was around the sensors and the drift and the accumulation of error over distance. And so I'm guessing that it's better sensors, better algorithms that allow you to correct for that error as you proceed along a route using dead reckoning. Is that true?
Yeah, so I think we saw the generation of iPhone that was around the iPhone 7 and a similar thing on the Android phones. At that point, you got a combination of things that worked to our benefit. One is the sensors got better, and they are still getting better. So the gyros and so on that we use. Also, the computational capability of the phone got more capable. And so really, anything since iPhone 7 and on, we've been able to create an algorithm that we first developed it from my previous company, an engineering company, where we were following blue light services into buildings which were unknown. So we were doing some amazing technology on bespoke devices and desktop-based analysis, and to be able to move that onto the phone has been an amazing sort of breakthrough for us, which is what we've built our company on.
Great. I mean, that's so important, because when you don't have to modify the infrastructure, it makes it more affordable. And that brings us to one of the key problems, which is mapping. And this is why our company was formed and why we're called Goodmaps, is because that's really where it's all at. If we can get a handle on the positioning, then what about the maps? And a very small percentage of buildings are mapped. Airports, baseball stadiums, some large facilities. There is positioning now in LED lights, and some big companies like Target and Home Depot that they're really using for their staff and position and their own staff and stocking, but the consumers aren't using yet. But we're turning the corner where that kind of thing can be used. But how do you map these buildings, particularly if you're not a huge company that's going to invest in this? And how do you scale this? And I'll share my opinion after I touch base with both of you guys on how do you think we're going to get these maps to sync up with this cool positioning that's starting to happen, Nick?
Yeah, this is the area, the actual process that's really critical. I work in this part of it the least. GPS outdoors, a lot of people don't even think about it, but underlying all why your GPS works is it's hitting an underlying map or a GIS. And as Mike said, there just aren't consistently done or even done at all in most indoor settings. But just one thing to add to this, Mike and Tim are working on these issues. What a lot of people don't think about, though, is the big companies that are working on these, like Google and Apple. They may get this mapping technology figured out, but a lot of what they won't have are information that are useful to blind folks for orientation. So something like, change in carpet, something under feet, texture, carpet, brick, wood. Those can be really important cues to give in a description, or something about the wall, or something about, different sounds, smells, feels. These are things that may not be in a normal, a traditional map that's used in a device, something that Apple may roll out or Google may roll out, but may be really critical in something that as blind individuals and blind users would want to use. And so I'm really excited that the mapping that you're doing, Mike, through Goodmaps, those are going to be able to be shared, because people will be able to build on this information, I'm imagining, and being able to put it in there, which will be really critical for blind users.
Yeah, well, the interesting thing about maps is when you think about it, they're the hardest thing to make accessible. And that's because a map is a graphic, it's a picture. And so short of doing video description or image description for every one of these, and more of that is happening by Apple, by Facebook, by others. How do we do it in the context of wayfinding for streets? How do you tell somebody it's a 4-way intersection, or it's an 8-way intersection, and these kinds of things? And then indoors, you don't have street names, you have hallways, and they're not named. They're just a hallway. So there's a lot of challenges indoors, and that's really where we need to all collaborate, both in the scaling prospect, but also in the presentation. So we figure out in an indoor setting, how do we convey this picture, this map picture, to the blind user? Tim, what do you think about this?
I'm a massive supporter in the whole area of mapping, and I think it is the key that unlocks everything. And actually, so one of the things, if we look at Apple, they have a indoor mapping data format, IMDF, that they use, and it's really interesting. If you look at that, that has been designed to help a shopping mall lay out the shops inside a large mall. I mean, that's basically how it's designed. It's a bit more than that, but that's sort of where you can you can see their focus when you look at the standard. And actually, by extending that and creating a new standard, so we're a big believer in standards, because standards being that people collaborate to come up with a solution that people adopt. And if we get the right standard there, then what that means is that we can actually distribute the map creation exercise to everyone. So if everyone creates maps to a common format and a common approach, building very much on what's already out there with IMDF and others, then we believe that actually having open accessible maps that are free to everyone, where lots of different applications can work together, providing different elements of expertise, we think that's an amazing way to go forward. And we are actually getting behind another standard, having worked very hard on the audio standard, and recently just about to publish one on cognitive impairment. So how we give first-person instructions to those people who need a different mode of instruction. We're now getting behind another standard for the mapping, and for us that's really important. If we can evolve a standard approach to doing a mapping, then it means that it's not just down to the likes of Mike and myself to generate those maps. Actually, everyone can do those maps, and everyone can share those maps, so that we can then get your local school or your local office or restaurant to participate in a way that otherwise it would be impossible to do every building on the planet for one company. This is very much something that we want venue owners to participate in and contribute to, so that we can all benefit from it.
Yeah, and of course what you're referring to is the power of crowdsourcing, and this has been done in so many different ways in terms of information and mapping points of interest. And it's something that I've really embraced from early days of working on accessible navigation, calling what we called user points of interest. And that really augments the commercial database, of which there's millions of points of interest, but there are ones that might be specific to a blind person that a sighted person may not necessarily appreciate or need. And this folds into another principle, which is the more we can piggyback the mainstream, the more affordable and accessible these things will be. And you look at, for example, in doing routing, with Apple and Google and your normal maps, they are accessible, but for a sighted person, they want to hear, where do I turn? They don't want to hear about all the details in between. Whereas as a blind person, I'm more interested in the details, and I want to know the name of the intersections and where to turn and what are the names of the streets. The same thing happens in other venues. In airports, if you get to a gate, the sighted person could see a map that shows them the route from to their connecting gate. A blind person can't benefit from that because it is a graphic. So how do we piggyback that commercial data so we make it affordable, but we provide the user information to the blind person that makes it accessible? And that's really combining the best of both worlds, and that's how we that's one of the ways that we try to scale maps, by using commercial maps that are out there in addition to ones that we're going to create. Nick, I think you were going to say something about that.
Yeah, just one more thing that I think builds on both of these things. So there's still a lot of benefit that can get out of the mapping component and the UI component, even if the positioning isn't totally correct yet. And we're seeing this, but I think we'll increasingly see more systems using abilities to do pre-journey exploration and virtual navigation, where you can go, the research is very clear. People benefit a lot by being able to explore something ahead of time and building up their cognitive map or their mental representation of the space, which really helps to just build confidence and build an idea of where you're going when you actually get there. And even if the system isn't perfect, you kind of have already been able to build in a lot of your knowledge of what's there and where you're going from your house as you virtually explored. And I think that's really important, and increasingly that's being done. And I think that's, as we can add to that and build on user-defined attributes, I think that's going to be something that's used more and more.
Yeah, Nick, thanks very much. We're approaching the end of our time, so I'll shoot it back to Tim for closing comments. And if somebody wants to reach you, you might mention a contact for that.
Sorry, Mike, you broke up on me just at one vital point there. So I hope I respond appropriately. So just to say on the mapping, so I think it's really interesting looking at the mapping that actually that starts to open up another layer of detail, which we've done some amazing work on, is that if you were to do a satellite navigation route in your car, you use the roads to create a graph to be able to create a least cost route. That's how that works. But if you're a vision impaired person walking around a large building, the routing is you don't have those roads. You have corridors, but actually you have large open spaces too. So it's much more akin to sailing than it is to driving. So actually in generating the route calculations for that experience in an open environment with an open map, then some really interesting new algorithms that we've been working on that are actually much more taken from the world of sailing to be able to take people through a building, no longer having to force people to walk along a wall, because we can take them directly across a room because we can guide them. And I think there's some really amazing new things that we can do because of the emerging technologies that are coming through at the moment.
Great, Tim. Thanks so much. I want to thank my colleagues, Tim over there in the UK and Nick across the country at the University of Maine. This is Mike May from Goodmaps, and please be in touch with any of us. Goodmaps.com is where you could reach our company and reach me, and we'd like to continue the discussion further and help us in getting the world mapped. Thank you very much for having us, and back over to Will.